Good morning, friends. The topic for today's discussion is concept of simple interest. This topic is a very important topic in arithmetics. The topic that we studied somewhere starting from class 7th, 8th, and that topic you will find also very important in your day-to-day life, as well as from competitive point of view. That's important concept. So now in this lecture we will discuss about this topic, formulas that we have to use, basic concept involved, and different type of problems, use of alligation mixture in solving the problem of simple interest. Each type of thing we will discuss in the topic. Now before starting with the concept, I just want to start with the basic terms that we use. First term that we use is principal, that is taken as P, rate of interest, that is taken as R%, time, that is taken as T, then SI, which means simple interest, amount, that stands A, and amount is always equal to principal plus simple interest. We can say this amount is equal to principal plus simple interest. So these are some basic terms that we use in this topic: P, R, T, SI and A. Now before going further, I want to discuss what is the meaning of term simple interest. In the simple interest, our principal will remain same. In simple interest, our principal will remain same. That means you always get interest on this principal. You always get interest on this principal. You will not get interest on interest as in the case in compound interest you get. So in simple interest, if rate of interest is same, throughout the year you know that how much interest you will get, because you get interest only on the first principal on which you invested the money. The basic formula that we have in this topic is SI is always equal to P into R into T upon 100. That simple interest is equal to principal into rate into time upon 100. When we take R as rate of interest, that is always taken as PA. That PA means per annum. In that case, the time that we take, that is always taken in years. Because the formula that deals with P into R into T upon 100, in this we take R as rate of interest, that is taken as per annum. It means the time that we have to consider, that must always be taken into years. The first type of problem that we start with it, in which where time is not given in the years, the different type of times may be given. That may be given in year and month. It may only be given in month. It may be given in year and days. So first we start with this type of statement. If principal is rupees 10,000, rate of interest is 10% per annum, and in the first case timing is equal to 2 years and 4 months. So I know that if I have to apply the concept of the simple interest, so I first of all I have to convert this timing into the years. So I know that in 12 months we have a year, that 4 months would be taken as 2, 4 upon 12. Now this is converted into years, so that would be 2, 1 by 3, or I can say 7 upon 3 years. I have to find the simple interest. This would be taken as principal into rate into time upon 100. Just solve it. Answer equal to 7,000 divided 3 rupees. That is the concept of simple interest. This is the simple interest. Right? On the other hand, the timing may also be given in days also. Generally we know that in a year we have 365 days. If nothing is mentioned, we take it as 365. If it specifies that it is a leap year, in that case we take it as 366. In the same question, if I change the timing is 2 years and 73 days. Principal is 10,000, rate of interest is 10% per annum, and the timing is 2 years and 73 days. I have to find the simple interest. First step that I have to follow, I will convert this years into days and years into years. So I know that 73 would be taken as 73 upon 365 or 2 1 by 5, or that is taken as 11 by 5 years. Now just put here as principal into rate into timing upon 100. Just solve it. 5 will go on 2 and answer is equal to rupees 2200. This is taken as a simple interest. I hope the first point is clear to you, in which we just understood when the timing is not given into the years, so we convert them into the years. When months are given, we divide by 12, converting into year. When that is given in the days, we divide by 365 and that will be converted in the years. Then we have second type of problem in which rate of interest is not fixed. Rate of interest is not fixed for every year, that goes on changing. For example, it is given that principal is rupees 10,000. For first 2 years, rate of interest is 10%. For next 1 year, rate of interest is 20%. For next 2 years, rate of interest is 25%. So I have to find out what is the total simple interest in 5 years. That's my statement. Pay attention here what the question is. It is given that the principal is 1000, the principal is 10,000. For first 2 years, rate of interest is 10%. For next 1 year, rate of interest is 20%. For next 2 years, rate of interest is 25%. And I have to find out what is the total simple interest in 5 years. Now when I look at these type of problems where rate of interest is not fixed for different years, so we can use the standard formula here. P is the principal. For first T1 years, rate of interest is R1%. For next T2 years, rate of interest is R2%. For next T3 years, the rate of interest is R3%. And I am supposed to find out the simple interest. So that simple interest is equal to P into R1 into T1 plus R2 into T2 plus R3 into T3 upon 100. That simple interest is taken as principal into R1 into T1 plus R2 into T2 plus R3 into T3 upon 100. So in this question what I can say, the simple interest is, my principal is rupees 10,000. For first 2 years, the rate of interest is 10%, so 2 into 10, 20, plus for next 1 year, rate of interest is 20, 1 into 20, 20. For next 2 years, rate of interest is 25, 2 into 25, 50. Upon 100, just solve it. 100 into 90, so I can say simple interest on this sum is rupees 9,000 for 5 years. I hope the concept is clear. When rate of interest is different for different years, in these type of questions, if I have to find the simple interest, that simple interest is equal to principal into R1 into T1 plus R2 into T2 plus R3 into T3 upon 100. Just simplify this and you find your answer is equal to rupees 9,000. Then we have third type problem. In third type problem, we take the case of change of interest. Change in interest. timing is 2 years, and the question is what is change in simple interest? What is the change in simple interest when rate of interest changes from 10% to 15%? Just look at the question, what it talks about. Suppose principal is rupees 10,000, timing is 2 years, and we have to find out what is the change in simple interest when rate of interest changes from 10% to 15%. Or the question may be also in this shape, principal is 10,000, rate of interest is given, and he may say timing changes from 2 years to 4 years. So we have a very standard concept here. Change in simple interest, change in SI is always equal to what is fixed P, what is fixed T, into the difference between the rate of interest R1 minus R2 upon 100. That becomes my answer. In a question where the rate of interest and the principal is fixed and there is a changing in time, in that case it becomes P into R into T1 minus T2 upon 100. Suppose there may be also a question where rate and time is fixed and we have to, and the difference in principal is given, we have to find the change in simple interest. So this would be taken as R into T into P1 minus P2 upon 100. That is the change in simple interest. Now for this question, I have to find what is the change in simple interest. So what I will do here, the rate of interest changing from 10% to 15%, I will simply make it as 10,000 is the principal, 2 is the time, and the difference is 15 minus 10 upon 100. Just solve it. 200 into 5, and answer is equal to 1000. So I can say the change in the simple interest will be rupees 1000. That means question may be any of the type. It may be either where change of time is given, we have to find the change in simple interest, or the question may be where two different principles are given with the same rate as well as the same time, we have to find the change in the simple interest. So in all these type of questions we can apply this and we are in a position to get our answer. Then we have fourth type of problem, very important type problem and also very simple, and sometimes you commit mistake in these type of problems. What this question talks about, it is given that a sum becomes 5 times in 20 years at simple interest. Question is, a sum becomes 5 times in 20 years at simple interest. We have to find what is rate of interest. The question is, we have to find what is the rate of interest. So first I will start with your conceptual method, then we will make a shortcut formula for this. Suppose I say the principal is equal to P. It becomes 5 times. It means amount becomes 5p. And what is the simple interest? The difference between amount and the principal. So I can 5p minus p. This is equal to 4p. That is the simple interest. Now I can say the timing is 20 years. I have to find the rate of interest. So we can say that if my basic formula SI is equal to P into R into T upon 100. So I can say R is equal to SI into 100 upon P into time. What I can say here now, if my simple interest is 4P and the principal is P and the timing is 20 years, so I can say R is equal to 4P into 100 upon P into 20. 20 will go on 5. 5 into 4, 20%. So my answer is equal to 20%. Just have a look over the statement. What I have done, have taken my principal to be P and it becomes 5 times. So I can say amount equal to 5P. The difference between the principal and the amount is interest. So I can say the interest is 5P minus P. This is equal to 4P. Now what I can say, interest is 4P, principal is P, R equal to SI into 100 upon P into T, just solve it, and R is equal to 20%. We can have a very small shortcut formula for these type of questions where a sum becomes n times. So I can just compare it with a sum becomes n times in T years. What the statement is, a sum becomes n times in T years, and I have to find out what is the rate of interest. This is n minus 1 into 100 upon T. Or if I have to find the time when the rate of interest is given, so my formula would be T equal to n minus 1 into 100 upon R. So when we look at these questions, means two type of question can be asked. In the first, either you have to find the R percent or you have to find the T. So what I can go for it, I can assume that a sum become n times. So I can say n minus 1 into 100 upon T. Suppose it is given that a sum becomes 5 times, so I will take it as R percent equal to 5 minus 1, 4 into 100 upon T. And the timing is 20 years. I will put here 20. 20 will go on 5. My answer to this question is 20%. That becomes my answer. Right? Now I am going to state you a question in which you have to apply these two formulas so that we understood how to use this. It is given that a sum becomes or a sum amounts to 6 times in 40 years at same rate of interest, after how much time it becomes 14 times. Pay attention here what the question talks about. A sum amounts to 6 times in 40 years at same rate of interest. If the same rate of interest follows, how much time it takes to become 14 times? So when I find the rate of interest, so what I can say, R percent equal to 6 minus 1 into 100 upon 40. That would be 22, 25, 25 by 2%, that is said to be R percent. Now the question is, if same rate of interest follows, that means my rate of interest is 25 by 2%, I have to find my time and sum becomes 14 times. So I can say timing is equal to 14 minus 1 into 100 upon rate of interest. This would be 25 by 2, or else I can say 13 into 100 upon 25 into 2. 25 will go on 4, 4 into 2, 8, 13, 8 the answer is 104 years. So I can say at simple interest it takes 104 years to make the same sum to become 14 times. That becomes my answer. Just look at this question, what I have done in this statement. First I have found the rate of interest. For finding the rate of interest I have used this, and once you have the rate of interest you can easily find the time applying the same process, that is n minus 1 into 100 upon T. You are n minus 1 upon 100 upon R, and you can easily find the value of T. Hope this is clear. So that is our type number 4. After this, we have one more type of question in which where equality of interest is given. Equality of interest is given. For example, it is given that Suppose there is a person, he has some money with him and he had given his money to three persons A, B and C. He divided his money to three persons in some ratio A, B and C. To A, he gives money at a rate of 20% per annum for 2 years. To B, he had given money at 10% per annum for 3 years. And to C, he had given money at 5% per annum for 4 years. What is given to you? There was a person and he had given his money to three persons A, B and C. To A, he had given at the rate of 20% per annum for 2 years. To B, he had given at a rate of 10% per annum for 3 years. And to C, he had given at a rate of 5% per annum for 4 years. Further, it is given that simple interest received from all the three persons. Simple interest received from all three persons is equal. We have to find out what is the ratio in which he gave money to A, B and C. Just look at this question. We have to find out in what ratio he had given money to A, B and C. When we go with the standard concept, how we can go for it? Assume A was given A rupees, B was given B rupees and C was given C rupees. Simple interest from A is A into 20 into 2 upon 100. From B is B into 10 into 3 upon 100. From C is C into 5 into 4 upon 100. That is equal, from here I can say 40A equals to 30B equals to 20C, or 4A equal to 3B equal to 2C. I have to find the ratio of A ratio B ratio C. That is taken as equal to 1, 1 by 4, ratio 1 by 3, ratio 1 by 2, or my answer is LCM would be taken as 12, this would be taken as 3 ratio 4 ratio 6. That becomes my answer. Its answer. Pay attention here what I have done. I have assumed that A had given A rupees, B rupees and C rupees. 20% to A for 2 years, that is the interest. 10% to B, that is for 3 years, 30B, and 5% for C, that is for 20C. From here I can say A ratio B ratio C, 1 upon 4 is to 1 upon 3 is to 1 upon 2, 3 ratio 4 ratio 6. I can also use the standard formula for these type of problems. What this formula talks about, when simple interest is same, when simple interest received is same, and the money given to the three persons at some rate and some time. Suppose R1 is for A and timing is T1 years. Similarly R2 for B and timing is T2 years, and R3 for C and timing is T3 years. Right? So when I want to answer this question directly, so what I will make, here condition is SI received from the three persons is equal. My answer is taken as 1 upon R1 into T1 is to 1 upon R2 into T2 is to 1 upon R3 into T3, and find the ratio. That is your answer. So what I can say in this question, 1 upon 40 is to 1 upon 30 is to 1 upon 20. I will get the same value, 1 upon 4 is to 1 upon 3 is to 1 upon 2. Just solving it, I can say answer is 3 ratio 4 ratio 6. That becomes my answer. Pay attention here, that is the first type problem in which I explained you where simple interest received from the three persons at the end of the given time period is equal. In that case, if I have to find out what is the ratio of the money in which he had given money to ABC, so our answer is said to be 3 ratio 4 ratio 6. We have one more question in this same type where what will be changed, that type number 6. In the type number 6, the whole question is same, and what is the changing point? Amount received is equal. Question is amount received is equal. Means it is given to you that ABC are the three persons. a person had given money to these three persons, to A for 20% for 2 years, to B for 10% for 3 years, to C for 5% for 4 years. It is given that amount received from these persons is equal. At the end of the given time period, amount received from these persons is equal. We have to find out in what ratio he had given sum to A, B and C. We can have a direct formula for this. 1 upon 100 plus R1 into T1, 1 upon 100 plus R2 into T2, 1 upon 100 plus R3 into T3, and our answer is there. Or you can also go with the standard approach, make all the amount to be equal. When I go with this, I can say 1 upon 100 plus 40 in the first instance, 1 upon 100 plus 30 in the second instance, 1 upon 100 plus 20 in the third instance, or my answer is 1 by 40, 1 upon 1 by 30, 20, or 1 upon 14 ratio, 1 upon 13 ratio, 1 upon 12. That is the money, that is the ratio in which he had given money to A, B, C. What I can say now, when amount received from the persons is equal, in that case, what should be our approach? Our approach would be taken as 1 upon 100 plus R1 into T1 is to 1 upon 100 plus R2 into T2 is to 1 upon 100 plus R3 into T3, and after solving this, my answer is there. Then we have one more type of question in which we use the concept of alligation mixture, or we can directly answer the question with our basic formula method. What the question talks about, suppose a person has rupees 20,000 with him. He had given this 20,000 rupees to two persons, one is A and one is B. To A, he had given at a rate of 10% per annum for 2 years, and to B, he had given at a rate of 15% per annum for 2 years. Then it is given that at the end of the 2 years, total simple interest received from these two persons is rupees 5,200. You have to find out how much money had been given to A and how much money had been given to B. Just look at the question. A person has total 20,000 rupees with him. He had given this 20,000 to two persons, A and B. To A at a rate of 10% for 2 years, to B at a rate of 15% for 2 years. At the end of the 2 years, he found that total simple interest that he received is rupees 5,200. We have to find out how much money he had given to A and how much money he had given to B. Now, when I look at this question, what I can say, we have two approaches in answering this question. The first one is our basic approach, that is taken as the general approach. I can assume that money given to A is equal to X. Then I can say money given to B is equal to 20,000 minus X. How much interest he received from A? X into 10 into 2 upon 100. How much interest he received from B? 20,000 minus X into 15 into 2 upon 100, and the total simple interest that he received is equal to 5,200. And I have to solve the value for X. That's our question. I will cross multiply. This would be 20X plus 30 into 20,000, that would be 6 lakh, minus 30X equal to, when I multiply this by 100, this becomes 5 lakh 20,000. Now that minus 10x goes this side, 10x, and here I get 80,000. So I can say x equal to 8,000. It simply means money given to A is equal to rupees 8,000. That is is rupees 12,000. That becomes my answer. Look at this question, what I have done in this statement. You have 20,000 rupees with you and you divide it between two persons A and B. So when that is divided in two persons A and B, so I can just solve my question on this way. So I can take this value as X, that would be 20,000X. This is the simple interest received from A and this is the simple interest received from B. I have to add these two simple interest and my total simple interest received is 5,200. After solving this, I can say X is equal to 8,000. It means money given to A is rupees 8,000 and money given to B is rupees 12,000. We also use one alligation mixture method in answering these type of problems. The method is quite easy. What is the rate of interest for A? 10%. What is the rate of interest for B? 15%. If I take this question as 20,000 is invested and after 2 years the man gets rupees 50,200 as interest. Means if principal is 20,000, timing is 2 years and SI received is rupees 5,200. When you find rate of interest from here, that is 13%. This 13% rate of interest is taken as the mean value or average rate of interest. So as we know that in the topic of alligation mixture, we put the mean value here. I subtract it silently, 2:3. I will get it as 2:3. Means I have to divide the total money 20,000 in the ratio 2:3. When I divide this 20,000 in 2:3, so 2 part is for A and 3 part is for B. So after dividing we get 8,000 for A and 12,000 for B. That's our answer. I hope the idea is clear to you. It's a very simple type question. 20,000 divided between A and B. Either I can answer this question by our traditional approach in which we just applied the concept of simple interest, or I can also answer this question with the alligation mixture technique that states me that A for 10% and B for 15%, and when I take the mean value, my mean value is taken as 13% that I put here. I just find the ratio, that is 2:3. That is the share of A and that is the share of B. So I divide this 20,000 is this 2:3 and finally I get 8,000 for A and 12,000 for B. So this is the concept of simple interest. I hope you enjoyed the lecture. These are some standard type of problems that are generally asked from this topic of the simple interest. Try to listen this one more time so that when you start to answer the problems, you can easily answer it. In the next lecture, we will discuss about the compound interest and the relationship between the simple interest and compound interest. Thank you very much.